This is the video for Exam 1, Section 2, Number 1b. Well, Number 1 in Section 2 asks us to consider the curve given by the following equation. Given by x y squared minus x cubed y equals 6. It also asks us to show, in 1a, it asked us to show that this was true, which we did. We actually showed that dy dx is equal to 3x squared y minus y squared over 2xy minus x cubed. Now, 1a was asking us to show that this is true. A good test-taking strategy, if you had a difficult time with 1a, you can use the helpful information they're giving you. They're telling us what it is. Let's use it. Let's use their version for 1b. No matter what happened in 1a, let's use what they're telling us it is in 1b. So what is it that they're asking us for in 1b? Well, it asks us to do this. It asks us to find all points on the curve whose x-coordinate is 1. And then it wants us to, it says, and write an equation for the tangent line at each of these points. Let's make sure we understand the problem. Okay, it actually kindly gives us the derivative. And it asks us, first of all, to find all the points on the curve. This is the curve. This is the equation that gives us the curve, whose x-coordinate is 1, right? What is that asking? Well, it wants us to find points where the x value, right? Every point is an x and a y. It wants us to find points where the x value is 1. Well, then what will the y value be? Well, we need to find that. We need to figure out what that y value is. And to do that, let's go back to the original equation. The original equation will be used to find these points. So we are told that the x-coordinate must be 1. So I'm going to go back to the original equation. The original equation is x times y squared minus x cubed y equals 6. And since x is 1 here, I'm going to substitute in a 1. So we have 1 times y squared minus 1 cubed times y is equal to 6. So 1 times y squared is y squared. And 1 cubed is 1, and 1 times y is y. This is equal to 6. What happens next? Well, this is an equation. It looks like it's a quadratic equation. I'm going to get it equal to 0. So y squared minus y minus 6 equals 0. And I think this can be factored. If I couldn't factor it, I suppose I could use the quadratic formula, but I think this can be factored. I'm going to factor this into two quantities, two binomials. equal to 0. Certainly a y and a y. Since this is minus 6, it means this is y plus and y minus. Can I think of two numbers that multiply together to be negative 6 and have a sum or a difference of 1 like this, negative 1? I think it'll be a y minus 3 and a y plus 2. Let's see, 2 times negative 3 is negative 6. 2 plus negative 3 is negative 1, so that looks good. That means that, what that means is that when x is 1, we have y must be negative 2 or y must be 3. So now we have our 2 points. Our 2 points are, let's say, I'll draw it here. We have 2 points of interest. These are the 2 points where x equals 1. The first point is x is 1 and y is negative 2. And the other is where x is 1 and y is 3. So those are the 2 points, and now we have to do the next part of this. So what is the next part? Now that we have the points, it says, and write an equation for the tangent line at each of these points. Well, I believe you know this. I believe you know that the equation for a line, certainly if you know the slope at a point, can be done something like this. Y equals the slope times the quantity of x minus some x value plus some y value. This is the slope point form of a line. So which of these things do we have? Well, we certainly have an x value and a y value. We'll start with this point first. We have an x value and a y value. Do we have a slope? We don't have a slope yet. What could we use to get the slope? How about if we use the derivative that they give us, since that's exactly one of the things that a derivative tells you. So let's use the derivative that they've given us to find this value of m. So let's see. I'm using my derivative here because I want to know, what is this m supposed to be? Well, it tells us that dy dx is equal to 3x squared y minus y squared over what? Over 2xy minus x cubed. And we're using this point. So the x is 1 and the y is negative 2. Let's simply plug those values in. So it's 3. The x is 1 squared. The y is negative 2. And this is minus negative 2 squared. You see, I'm just plugging in my x's and my y's. This is all over 2. Here's a 1. The x is a 1. The y is a negative 2. Minus x cubed becomes 1 cubed. Let's simplify the top. 3 times 1 times negative 2 will be negative 6. Minus 4. Negative 6 minus 4. This is over 2 times 1 times negative 2. This is negative 4. Minus a 1. So what does this become? I guess negative 6 minus 4 is negative 10. Negative 10 over negative 4 minus 1, that's negative 5. So what is the slope of the line, this line of tangency? Well, the slope is negative 10 over negative 5, which is 2. So there's our value for our m. That is the slope of the tangent line at that point. So let's use this now to write down one of the equations it's asking for. It's y equals the slope. That is the value of the derivative. It equals 2 times the quantity x minus, what is our value of the x? Well, our value of the x is 1. And then plus our value of the y right there. Our value of the y right there is negative 2. And here is 1 of the equations it is asking us for. Let's now find the other equation. Well, the other equation is when we're at the other point, and the other point is 1, 3. All right, so we're going to have to find the new slope. What is the slope of that line of tangency? To do that, we will plug in the value of x and y at that point. So we're going to find dy dx evaluated when x equals 1 and y equals 3. So this will equal, using the derivative that they gave us, this will be 3, the x is a 1 squared, times the y is a 3, minus 3 squared, that's our y, over 2, the x is a 1, the y is a 3, minus 3, oh no, this is an x, this is 1 cubed. So let's see what this comes out to. I guess 3 times 1 squared, so this is 3 times 1 times 3, this is 9. 3 squared is 9, so it's 9 minus 9 over 2 times 1 times 3 is 6, minus 1 cubed is 1. So 9 minus 9 is 0, 6 minus 1 is 5. 0 over 5 is 0. So the slope of the tangent line at the point x equals 1, y equals 3, the point 1, 3, the slope of that tangent line is 0. So what does that mean? Well, let's use this slope point form of a line. This is y equals m times the quantity x minus some x value plus some y value. And in this case, the slope is 0. So it's y equals 0 times the quantity x minus our x value was 1 plus our y value, which is 3. Well, 0 times anything is 0, so this is y equals 0 plus 3, so this is y equals 3. By the way, what kind of a line is this? What kind of a line is y equals 3? I'm hoping that you said this is a horizontal line. This is a horizontal line of tangency. Does that fit with the idea that the slope is 0? Yes, it does. The slope of any horizontal line is 0. And here we have satisfied everything. We've done everything the question has asked for. Let's take a close look to make sure that we found the points where x is 1. And how did we do that? Well, we went back to the original. We went back to the original equation and we replaced all the x's with 1s, and then we solved for the y's. And by doing that, we found the two different values of y when x is equal to 1. That gives rise to two different points. One of the points is 1, -2, and the other point is 1, 3. So we need to find a line of tangency for each of those. We did exactly that by finding the slope, by using the derivative, and then using the slope point form of a line. Here is one of our answers, and there is the other.